We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in December 2023. The problem is related to the question on inverse image of 0 of functions in the given context. And this question is from the section Real Analysis. And the question is under part B, which is a multiple choice question carrying 3 marks, bearing the question ID 704022. 4022. The given question is, let capital X be a non-empty finite set. It's a non-empty finite set, and capital Y is equal to the set consisting of F inverse of 0, where F is a real valued function on X. You have to read this carefully. F is not a given single real valued function, but F is any real valued function on X. That is the catch here. And which one of the following statements is true? We are given 4 options. Option 1, capital Y is an infinite set. Option 2, capital Y has 2 power order of X elements. Option 3, there is a bijective function from X to Y. Option 4, there is a surjective function from X to Y. Let's now discuss the solution of this problem in detail. We have a finite set capital X. Let the number of elements in capital X be n. Let the elements of capital X be x1, x2, x3, etc., xn. Agreed. Let script f be the set of all functions, be the set of all real valued functions defined on X. Now the question is, how many real valued functions defined on X will be there? They will be the cardinality of R to the power of number of elements of the set X, and the cardinality of R is C, a continuum which is uncountable. Therefore, there will be uncountably many functions f from X to R. So I have told you in the beginning itself, f is not a given single real valued function, but f is any real valued function on X. That means f comes from script f. Agreed. Given y is equal to f inverse 0, f is a real valued function on X. That means f belongs to capital script f. This is, in other words, it is the set consisting of the set of all x belongs to X such that f of x is equal to 0, f inverse 0 is f of x is equal to 0, where f belongs to f. So you take such functions coming from the script f such that f of x is 0. Collect all such x. That will be the set. It is a subset of x for this f. And go on collecting these subsets. They will constitute capital Y. Right. Let the script f be F naught, capital F naught, union F1, union F2, union Fn. Script F be partitioned like this, where what is F naught? It is the set of functions which do not map any element of x onto 0. So, F naught consisting of all those functions which do not map any element x1, x2, xn of x onto 0. What is F1? F1 is the set of functions which map one element of capital X onto 0. Likewise, for 1 less than or equal to m less than or equal to n, Fm is the set of functions which map m elements, m of the elements of capital X out of n onto 0. So, for 1 less than or equal to m less than or equal to n, Fm is the set of functions which map m elements of x onto 0. M takes the values 1, 2 up to n. Now, let's now discuss the solution further in the next slide. So, that's what we have done so far. Script F, and what is the meaning of F naught, F1, F2, Fn we have already explained. Now, y is equal to the set of all, the set consisting of the set x belongs to x, f of x is equal to 0. F belongs to f. Right. So, that is written as y naught union y1 union y2 union yn. Right. So, this is the definition of y, and now that y is now, we have already seen that the elements of y are subsets of x. So, y naught union y1 union y2 union yn, where what is y naught is the set of all those x belongs to x, f of x is equal to 0, f belongs to f naught. F belongs to f naught. And what is ym? Ym is the set of all sets consisting of x belongs to x, f of x is equal to 0, where f belongs to fm for 1 less than or equal to m less than or equal to n. Now, our goal is that we talk about y naught, y1, y2, yn, and see how many elements are there in these sets. Right. So, further, this y naught, y1, y2, yn are pairwise disjoint. Therefore, the order of y is equal to the order of y naught plus order of y1 plus order of y2 plus so on and so forth, the order of yn by the counting principle of addition. Agreed. We continue for the further discussion in the next slide. So, yes, now first we go to y naught. Y naught is the set of all those elements of x which are mapped to 0 for any f belongs to f naught. Any f belongs to f naught means the f naught consisting of those functions which do not send any element of capital X onto 0. That means it will send no element to 0. Such functions. So, let us look at the demonstration here. This is your real numbered line, that is R, and this is your X, and we are talking about f naught, capital F naught is where none of the elements are mapped to 0. There will be such functions, several such functions. For all those functions, that is in f naught, f inverse 0 is empty. So, y naught, the order of y naught is 1. And y1 is the set consisting of all those subsets of x such that x belongs to x, f of x is equal to 0, f belongs to f1. That means f1 consists of all those functions which map exactly one element of capital X onto 0. So let us see one such functions, right? Real numbered line, capital X, a finite set. So here is a f which is sending x1 to 0 and the remaining elements elsewhere. So for such function, not one function, there will be several functions in f1 doing this one. And for that, the subset, this subset is singleton x1. And in f1, there are other functions which will send x2 to 0 and the remaining elements elsewhere. Right. So now x2 is going to 0 and the remaining elements elsewhere. So the subset is singleton x2. So like that, for various functions f belongs to f1, you will get the subsets singleton x1, singleton x2, singleton x3, singleton xn. And out of n elements, how many singleton sets you will get? That is, what is the order of y1? That is nc1. Now we go to a y2. It is the set consisting of those subsets x belongs to x, f of x is equal to 0, f belongs to f2. f2 consists of all those functions which send two elements of capital X onto 0 and the remaining elements elsewhere. So there will be several functions. So one such function is sending x1, x2 to 0 and the remaining elements elsewhere. So what do you get? You will get a subset consisting of doubleton subsets consisting of x1, x2. This is for some functions of f2. For some other functions, it can be x1, x3. Two elements. The remaining elements elsewhere. Right, x1, x2. So the the subsets consisting of doubleton set x1, x2, doubleton set x1, x3, x1 and doubleton set x1, x4, etc. x1, xn, and start with x2, x2, x3, x2, x4, x2, xn, etc. At the end, xn minus 1, xn. All doubleton sets you will get. How many doubleton sets you will get out of n elements? You will get nc2 elements. So order of y2 is nc2. You go on doing it for m is equal to 1 to n. At the end, we will get yn. Yn is the set consisting of that set where every element is mapped to all the n elements. All the n elements are mapped to 0. All the n elements mapped to 0. There will be only one set. That is the whole set. And look at the demonstration here. Real number line x and all are mapped to this one. Right. So that is the singleton set, which is capital X, which is capital X, which is capital X. And what will be order of yn? N, C, N. That is one only. But anyway, we have to write N, C, N. Now we are ready to compute what is the order of y. Order of y. And we know the order of order of y0, order of y1, order of y2, order of yn we have computed. And finally, order of y is order of y0 plus order of y1 plus order of y2 plus order of yn. That is nc0 plus nc1 plus nc2 plus so on and so forth ncn. This is sum of all binomial coefficients out of n elements, and the sum is 2 power n. And what is n? N is the order of the finite set capital X. So this is 2 to the power of order of x. Thus order of y is 2 to the power of order of x. That means y has 2 power order of x elements, and this is precisely your option 2. Thus, the option 2 is true, and you may note down that y is, and the answer is option 2. Option 2. Right. You may note down that this y is the power set of x, is the set of all subsets of x. That is the power set of x, and your answer is option 2, and the discussion is practically over. Right. We have proved, is a multiple choice question, and we have proved one of the options is true. Therefore, you have to stop here. There is no need of going and showing that the remaining 3 options are false. And if you do not know which option is true, then you go on eliminating 3 of the options and say the remaining option is true. So that is the elimination process. But having proved this one and proving the remaining options are not true using the option which is true will be a waste of time, and that is not needed actually. But anyway, some of the students want this, how the remaining are not true. I'll show you, but this is of no use. Right. We have y has 2 power order of x elements. Option 2 is true. Option 1, y is an infinite set. Now see, what is x? X is a finite set. What is 2 power order of x? That is finite. That means y is finite. But it is given y is an infinite set. Therefore, option 1 is not true. Right. Right, that is the argument. Let's go to the next option. There is a bijective function from x to y. If there is a bijective function from x to y, then the order of x must be equal to order of y. But what is order of x? X only. Order of x is n only. Or what is order of y? 2 power order of x. That means n is equal to 2 power n. For no n, this is true. Therefore, this option is also not true. Then order of x must be equal to order of y. That is, order of x is equal to 2 to the power of order of x, and this is not true. When order of x is n, 2 power n is n. This is not true. So option 3 is not true. Option 4, there is a surjective function from x to y. If there is a surjective function from x to y, then order of y must be less than or equal to order of x. What is order of y? 2 power order of x less than or equal to order of x. And this is not true. So note that x and y are finite sets, right? If there is a surjective function from x to y, then order of y less than or equal to order of x. Order of y is 2 power order of x is less than or equal to order of x. For no finite set, this is true. Right? So this is not true. Therefore, this option 4 is also not true. Thus, what we have proved in the earlier, that the option 2 is true. Therefore, I summarize and say the answer to this question is option 2. And that is the detailed discussion of the solution of this problem, and it is definitely a difficult problem in the examination hall. There is no way of eliminating 3 of the options, and if there is a way, that will be very difficult and it will take long time. And I like this question. I am sure that you have understood the solution of this problem. If you like my presentation, my lecturing on the various topics, please like and share my videos and subscribe my channel. I wish you all the best. Thank you.